So what's up guys, in this video we explain nato ang concept sa moment of inertia. Without further ado, let's go. So ang atong goal ani nga shape is to determine the centroidal moment of inertia. So sa kani nga shape, we can either break this down into one big rectangle and then may nasan na nato duha ka triangles, gana duha ka triangles and this circle. Our option 2 is this is the given shape. We can cut this two triangles gihapon, but this time they are all solid into law. And then also this small rectangle here, solid siya, and then here hollow siya. So pwede na siyang options, or you can have as many options as you want, because we don't have a direct formula to find the centroidal moment of inertia of this specific shape. So again, what is moment of inertia? Moment of inertia is the cross-sectional resistance to bending. So I could have an axis here and bend my shape like that, ito, like that, or have an axis here that I will bend my shape like that. Alright, the value we'll get after computing the moment of inertia is how much this cross section resists that bending. Alright, that's what basically moment of inertia is. Now to compute it, we need to locate where this centroidal axis is located. Okay, since each of these shapes we've decided is scattered, their centroid of these specific shapes are not located in one common point. So that's gonna be our first goal, to locate the centroidal x-axis, right? Because moment of inertia depends on which axis we are taking off. Let's say for example, for a rectangle, if we take its moment of inertia about its centroid here and about this axis, dira ito siya pikoon. Ito siya pana dito. Ana siya pagpiko, ana siya pagbend. Right? Ana pagbend. This moment of inertia here is for rectangle siya BH cube over 12. But if we suppose fold this rectangle about its base, or the very bottom of it, the moment of inertia will change into BH cube over 3. That is why it is important to have a reference axis, and also so that we can locate where this x and y axis with respect to the centroid of the overall shape is located. So alright, that's our first thing we need to find, the location of this. Going back to this this idea here, that moment of inertia differs from what axis we're taking it on. Let's say this axis, let's say this is our IGX, or the centroid, or the moment of inertia of this rectangle shape about its center, ano siya, IGX, or center x-axis, and we want to transfer it to this axis here, or its base. Let's say this as an x-axis. So the key here to transfer this, and so we can have this BH cube over 3 moment of inertia of this shape about this point, is what they call the parallel axis theorem, or the transfer formula. All it says is the IX is just the IGX, or about this centroid of that shape, plus the area of that shape, or area of that section, times its distance squared. So what is this distance squared here? This distance is referring to this perpendicular distance between these two axes, about this axis and this axis. That's d1. And if you can notice here that if the height of this rectangle is equal to h, then this distance from the centroid of this rectangle to its base is going to be h over 2. And so that if you apply this in the formula, IGX is going to have, or this shape, its IGX is going to be BH cube over 12, plus the area of that rectangle is just base times height, times h over 2 squared. This is the distance. Yeah. And if you simplify that before, you're gonna have BH cube over 3. Ano siya about the base. So that's how you use the parallel axis theorem, or the transfer formula, which is also useful here if you are to transfer the moment of inertia of each this to the neutral axis. So sa solution nato nga gibuhat from this shape, overall shape nga given, yani gi-break nato siya into three shapes lang dire, because the triangles are the same shape ra maning kahilid niya, 50 by 400 ang height aning duha, then rectangle o circle ra, which is kanay negative ning area sa circle since hollow man siya. So explain na nako ang process. Una gi-calculate nato ang areas of each. So for rectangle, area 1, area 2 ning sa rectangle triangles, then area 3 ning sa circle, and then i-compute nato ilahang distances, centroid nila. Let's say this circle, this centroid of it padulong sa atong reference axis, which is at the very bottom. So we apply nato na same idea to the rectangle and triangles. Ano siya dire ilahon to this reference. So vital na siya so that we can solve the y bar later on. So dire mo taon buhat. The area 1 which is a rectangle is just 200 by 400. Man siya which is 80,000. For area 2 that is 0.5 or 1/2 base times height, that's triangle. 50 times 400 divided by 2 or 0.5 here. We got 10,000. Area of usa. And we have 2. So duha ra ka area pero dire i-rewrite ra na ko siya. Duha ka 10,000, 80,000 per area rectangle, then 20,000 per area triangle. And then for the area number 3 which is a circle, which doesn't exist in the original shape, is pi over 4 its diameter squared, 150 squared, 150. And we put negative sign here to denote that this area does not exist but vital in our calculation, since ang atong ibuhat total of this two triangles and rectangle minus this. So we got overall total area of this cross-sectional shape is 82,328.54. Stored na to at m sa atong calcu. And the distances of each centroid of the of the shapes. So again, the distances y1 or the area 1 or the rectangle's centroid is distance to the reference axis is just, kita niyo yung height is just 400 over 2 or 1/2 of the 400 which is equal to 200. And for the duha triangles in same silag level, that's just 2/3 of 400. It's height 2/3 of 400, that's 800 over 3. And for y3, the circle, given naman nga 200 siya, or that's 1/2 of 400. 200. Then to calculate the centroid y bar of our shape, or in other words, the location of the x-axis with respect to our reference axis, this is supposedly y bar. It's just you multiply the area of shape 1 times its centroid's location from our reference axis y1 and so on. We have two area here for triangle, and this area is area 3 and y3. This area is supposed to be negative since circle does not exist. And we apply that, you can see negative there. And we got 216.20. So this location of our xc, or the centroidal x-axis of the overall shape from our reference axis, is 216.20. Now, we need to transfer these centroids to the neutral axis in order for us to find the IXC, or the moment of inertia, about the centroidal axis of the overall shape. That's why we have D1, D2, and D3. So to solve that is just the absolute value of, we take advantage of the y bars so that di ta malibog sa pagkuha ani. Because let's say for example, we need to find this area, this length. This length, we can say that this is this length minus the y bar, or pwede po yung y bar minus this bigger area, we'll get negative. So, absolute value lang na, and we got this 16.20, 50.47, 16.20. Then apply that ang moment of inertia of each, bh cube over 12 plus area d squared plus duha sa triangle. This is for triangle, bh cube over 36. For circle, that's pi over 64 times 150 to the 4th, or diameter to the 4th. Then area, and then the D1, D2, D3. Then minus ning moment of inertia sa circle. And we get IXC, or the moment of inertia about the centroidal x-axis of the overall shape. Kung piko na to siya, paano ang shape, is equal to 1,386.9 times 10 to the 6 mm to the 4th.